Hello everyone, myself Sai Prasad, Alex in Allahabad High School in the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started the chapters of 2A starting from complex numbers, De Moivre's theorem. Then we learned a few binomial theorem, permutation, combination, right? Fine. After that we started the statistical chapters, that is measures of dispersion, right? Fine. What did we learn in that? We just learned what is mean and everything, which is just analyzing the data. How do we represent a data and how do we analyze it? Okay, that is what we do when we have enough data, right? There is no thing of estimating the next upcoming data, isn't it? Whereas the thing which is used to analyze the data which is going to occur, right, that is nothing but our probability. What is probability? It is simply just a possibility of getting an outcome, whether it is random or whether it is not random or which is expected, right? It has to be within the space. What is that space called as, and all those. Okay, these are the general things which you can learn. Yes or no? Fine. A probability is such a chapter whose applications are not only in mathematics or in statistics but also in your sciences such as computer science or electronics. Fine. That is only to estimate the result of any experiment. We use a probabilistic methods to learn. Clear? Fine. What is that we are going to learn in this chapter is, we'll just learn the basics of probability as we have learned in our previous sections. Fine. You learned about what is probability, what are the conditions and basics, right, in your lower classes. After that, now we are going to take the basic examples such as die, coin. Okay, with this we will learn more activities. Okay, that is not only single dice or not only single coin. We'll have multiple number of dice, multiple number of coins. Okay, so that we can estimate the number of outcomes in different conditions. Okay, and we'll also learn the basic conditions of probability. Okay, when a given case is said to be having this kind of probability, or what is the range of expected things. Okay, fine. Later we will learn three different theorems which are the basics of whole probability. Those are addition, multiplication and Bayes theorem. What are these and everything we will learn in detail. Fine. Okay. So shall we start the chapter? Right. See here. What is an experiment, or simply what is a random experiment? A random experiment is something, whatever we do, the experiment result is unknown. Okay. Let us say if I toss a coin. Okay. If I toss a coin, tossing a coin is an random experiment. Yes or no? Fine. Tossing, the work done, it is a random experiment. Why is it called as random? We don't know whether we get a tail or head. Okay. What if I know, let us say I tell I'll get only tail, right? So we can just tell a random experiment is something whose outcome is unknown. Clear? Is it fine? Okay. Next, what is a simple event? A simple event is nothing but a simple outcome. What is an outcome? Just tell me. Let us say my experiment is tossing a coin. Okay. Then what are the outcomes? Outcomes are maybe a tail or a head. Is it fine? Okay. So what is a sample space? A sample space is a set of outcomes. Set of outcomes. Is it right? Yes? Fine. Then what is an event? First of all, what is a simple event? It is just a result of any outcome, right? Fine. What is an event? Simple event is single result. Event is combination of all of all simple events. Okay, that is nothing but it is simply let us say outcomes. Tail is one, head is one separately. Those each are called as events. Clear? Sample space is the set of all outcomes. Clear? What if I throw a die? The outcomes are 1, 2, 3, 4, 5, 6. This is a sample space. Okay, so we will just write it as 1 sample, less than 6. Yes. So what does this mean? Whatever it is, we are going to get the outcome only within this range. Will a dice have more than 6? No, right? So we can just remember sample space as set of all outcomes. Clear? Did you understand? Fine. And there are different conditions if we have 2 or more sets. Clear? Among them, the first basics are mutually exclusive events. What do this mean? Mutually exclusive events, it indicates that let us say A and B belong to same sample space, right? Then the probability of A occurs when the probability of B is not there. Okay, or simply I can tell that A will occur only when B doesn't occur, or B will occur when A doesn't occur. Clear? Or we can simply say it as A and B are disjoint sets. Let us say A has a set of 1, 2, 3, B has a set of 4, 5. Okay? Yes or no? Fine. Do we get the values of B when we are with the values of A? No, right? So A and B doesn't have any common term. That's why I wrote it as A intersection B is equal to 5. Clear? Then such events are called as mutually exclusive events or simply disjoint events. Right? Mutually exclusive events. Right? Exclusive in the sense one doesn't depend on another, or simply I can tell like the probability of one event occurs only when the other event doesn't occur. Clear? Fine. Next, mutually exhaustive events. What does this mean? Exhaustive. It clearly indicates that one event, if there are 2 events A and B, okay, even if one event occurs, the whole probability will, even one event occur is also more than enough. That is nothing but all the sets, everything, it belongs to a same sample space. Clear? An event occurs only when any one of the event occurs. Clear? Did you understand? Fine. So these are the basic things which you can easily remember. Is it clear? What did we learn? Just what is a random experiment, what is simple event, sample space, event. Mutually exclusive events are when one event occurs, one more event doesn't occur. Okay? Mutually exhaustive event means any one of the event occurs also, it's okay. Both are also is fine, or any one is fine. Clear? Did you understand? Shall we do few basics of probability and this identify mutually exclusive and exhaustive events? Let's do. Look at the question here. He is telling that in the experiment of throwing a die, consider events A. Okay, first of all tell me what is the sample space when we throw a die? Sample space is a total set of outcomes. What are the outcomes we get from our die? 1, 2, 3, 4, 5, 6. Isn't it? First thing, check whether the given events are within the sample space or not. If they are not within the sample space, then we can tell that this is a wrong event, isn't it? So just have that kind of clarity. 1, 3, 5. Yes, 2, 4, 6. Isn't it? Okay. Then just see here. there is a sample space, then he is telling that A, B, C to check whether these are mutually exclusive or not. When do we say the given events are mutually exclusive? When they are disjoint, which means that the intersection of those two sets, any two sets it might be, there are three sets, whether it is A, B, B, C or A, C, the intersection should be a empty set. Okay, just see here, there are two sets, let us say A intersection B. What do we get? A intersection B, 1, 3, 5, 2, 4. Is there any common term? No, right? Here it is 1, 3, 5, 2, 4. So it is 5, which is simply an empty set. Right? Next, B intersection C, let us see. 2, 4, here 6. Again, no common element. Then let us see A intersection C. Here also, here it is 1, 3, 5 and here it is 6. So there is no common element, which is 5. Yes. So all the three combinations are empty sets. So I can tell that A, B, C are mutually exclusive. Is it? Fine. So let us check the next question. In the experiment of throwing a die, A is 2, 4, 6, B is 3, 6, C is 1, 5, 6. Check whether these are exhaustive or not. What do we mean by exhaustive? These all should be within sample space. Right? Just let us say the given A is equal to 2, 4, 6, B is equal to 3, 6 and C is equal to 1, 5, 6. Is it? What is sample space? Sample space for a die is 1, 2, 3, 4, 5, 6. Clear? What do you mean by exhaustive events? The union of all the elements should be the sample space. We should not leave anything. Clear? That is one more thing you have to remember. Okay? Remember that an exhaustive condition satisfies only when the union of all the elements, union of all the sets is sample space. Clear? Just see here, A union, B union, C. Let us write everything. 2, 4, 6 union, 3, 6 union, 1, 5, 6. Now just let us write 1, cut 2, how many times? Only 1. 3, only 1, cut 4, only 1. 5, cut 6, 1, 2, 3 times. Now just check 1, 2, 3, 4, 5, 6. Is it a sample space or not? Yes, obviously. So we can just simply tell these three events are mutually exhaustive. Right? Therefore, A, B, C are mutually exhaustive. Is it? So, just tell me, when do we say exclusive and exhaustive? Can you frame few examples? Yes, right? Fine. These are the basic things based on exclusive and exhaustive condition. Shall we go to the next question? Let's do. See here, we learned what are basic events. When do we say the conditions such as exclusive, exhaustive, right? Fine. With all the basics of that, let us learn the basic definitions of probability. There is a theoretical or simply a mathematical definition of probability. Okay, that is, if any random event has n mutually exclusive, equally likely, exhaustive elementary events of and m of them are favorable to happening of an event A, then the probability of event A is given by. Okay, what does this mean? Just see here, if a random experiment has n mutually exclusive, exhaustive and different events. Okay, if there are total n number of events, okay, that is, it has n outcomes, out of them m of them are favorable to happen, okay, for an event A. Okay, yes or no? Then we can say that the probability of getting event A is nothing but m are the favorable things by total number of outcomes, or simply we can write as probability is given as number of favorable outcomes divided by total number of outcomes. Is it right? Yes? Fine. So with the basic knowledge, can we find the basics of throwing a coin, tossing a coin, right? What are the outputs we get for tossing a coin? Tossing a coin is an experiment. Then what are the events we get? T and H. There is a sample space. Then I say that an event, the probability of getting a tail, probability of getting tail. What do? Probability of tail is given by how many times are we getting tail? Only one, right? How many total events are there? That is, total outcomes are 2. So the probability of getting a tail is 1 by 2. Clear? Obviously the probability of getting a head is also 1 by 2. Head is 1 divided by total number of outcomes, right? So we can just simply tell, like, if this is a successive probability, then we can tell this as failure probability. Clear? Yes or no? So the sum of successive and failure probability, let us say this as PA, then it can be written as P into A bar. The sum of successful and failure probability is always given as 1. Clear? Half plus half, right? This is one thing you have to remember. And not only that, just try to understand the notation. Whatever we do, this is completely a kind of counting, whether it is 1 or 2 or 3 or many, right? Do we have any kind of counting less than 0? Obviously no. So the probability is always a positive value. Probability is always positive, right? Or simply I can write it as P of A is always greater than or equal to 0. Clear? And a probability is something like a possibility, right? Let us say in terms of percentage. If I say a person will feel hungry, what is the possibility that he'll feel hungry at 1 o'clock? It may be 50-50 chances, right? Which means that 50% or pakka he'll definitely feel hungry, then I can say it as 100%, right? If I say he will never feel hungry at 1 o'clock, we'll write it as 0%. What does this mean? 0%, percent in the sense divided by 100 to 100%. What does this mean? 0 to 1, or simply we can tell as the probability always lies between 0 and 1. Is it? Yes or no? Fine. Next, one more thing you have to remember for probability is, here we have 2 events. Whatever events we have, if I add those both, I got it as 1. Yes? Right. So let me take any other example. Let us say die. Okay, if I throw a dice, then the probability of getting 1 is 1 by 6. Even if it is 2 also, it is 1 by 6. 3, 1 by 6. Whatever number we get, we'll get only one number. The probability of each number is 1 by 6. If I add all 6 probabilities, we'll get 1 by 6 6 times, which is 6 by 6, which is again 1. So simply just what I want to tell is, the total probability for any experiment, the total probability for any experiment is always equal to 1. Is it right? What all we learned here? Just we learned the basic definition of probability as number of favorable outcomes by total number of outcomes. Then the failure probability and the success probability is always equal to 1, or simply we can tell as the total probability is always 1, right? Next, probability is always has a positive value, which means it is greater than or equal to 0. The probability always lies between 0 and 1. right? And one more thing is total probability is always equal to 1. Clear? Is it fine? What all we learned today? We just had a broad introduction about what is probability. Then we did few definitions. Yes. After that we did this this classical definition of probability and few basic discussions about it. Right? So we have to keep these kind of axioms in mind during solving a problem in probability. Clear? Fine. This is for today. Let us meet in the next session with more problems of probability. Thank you.